Hello all, I wanted to record this video to show you an alternative way to solve exponential equations. It's very similar to the previous method. We're effectively doing exactly the same steps, it's just presented in a slightly different manner, so it might add a little bit more clarity to the process. The other way also involves a little bit more intuition. This is pretty much, I guess, what we'd call the substitution method, for lack of a better name, because we use substitution to try and simplify the problem, get some answers, and then substitute back to get the proper answer in terms of x in this case, or if we were trying to find theta or whatever it is. But let's have a look. So we'll do example A first. So we've got 3 cos 2x minus pi on 3 is equal to 0. So the first thing we want to start doing is just rearrange it so that we get just a trig function left, or on one side. So we have x minus pi on 3 is equal to 0, because divide both sides by 3, 0 divided by 3 just stays as 0. So we get to this point, and this domain, I'm just going to actually undo that. So that's what our first steps are the same. From here, we could think of this bit in here, that's sort of our g of x, because we've got a function sort of inside the trig function. But we're going to do that whole g of x, we're going to let that just equal to something. In general, just let it equal to a. So I'm going to, at this stage, let 2 bracket x minus pi on 3 equal to a. So now my problem is cos a is equal to 0. So that's fairly straightforward. Since we've changed, and I can move some stuff. Oh no, I've cut that in half. Let's just undo that. We want to get this. One sec, sorry about this. Done that over there. 4 in our original problem. Okay, this was 4 when x was an element of 0 to pi. We had to solve that equation given that condition of x. Now we can't continue and write here x given 0 to 2 pi. Can't do that because this function is no longer a function of x, it's a function of a. So we need to adjust our domain, and so this is that idea of that working domain coming in, but we're just making it a little bit more explicit in getting that. So if we look at our original domain, we need to adjust this to be in terms of a. Well, we have an equation that converts any of these x values to a equivalent value in our a space. We could call it a space like that. So we'd substitute this 0 and this 2 pi into this here to figure out what our domain is in terms of a instead of in terms of x. So we're going to get a as an element of, we substitute 0 into that, so we get 2 bracket 0 minus pi on 3, and then we also substitute 2 pi in, minus pi on 3, square bracket. So a needs to be within the domain of 2 times, so that's going to be negative 2 pi on 3, and 2 pi, by that is 4 pi. Put some little scribble over here. So 2 times 2 pi is 4 pi, equate 2 by, so that's going to be the same as 3 and third pi. 3 3s are 9, so that's going to be 10 pi. We get 10 pi on. So that is our domain in terms of a, because we're now solving this equation where it was written as a. And by having done this substitution, let it equal a, this looks a whole lot less daunting. Not getting rid of everything else is like, oh, cos of what angle or cos of what values of A is going to give me 0? Well, from that, to get cos, to get 0, that's a horizontal component, so that needs to occur at either, that will be pi on 2, it will also occur at 3 pi on 2, it will occur at 5 pi on 2, and this is all just the when the line is going straight up or straight down. That's pi on 2, that's 3 pi on 2, and then just going round and round and round in circles, keep adding them up until we get to our domain limit, which happens to be 10 pi on 3, which is just over 10 pi on 3. What did we say? That's 3 1/3 pi, so that would be around once, around to here, and then around another pi on 3. So there. So 5 pi on 2, nothing larger than 5 pi on 2 works. But then we also have to negative 2 pi on 3, which would be going in the negative direction, is around this way to about there. So that actually also includes negative pi on 2 would also be a valid solution. So let's add that to our list, negative pi on 2. So that's using the ideas of symmetry. But we got A. We got A really, really easy. The only problem is we don't want an answer for A, we want an answer for X. So we now need to effectively substitute these 4 values back into our original sort of transformation, or not transformation, I don't want to use that word, conversion equation, and figure out what the matching or equivalent X value is. To do that is you could substitute this in for A, so for one of them we get pi on 2 is equal to 2x minus pi on 3, rearrange all that to get x by itself, then you're going to have to do the exact same thing for the next one, is equal to 2x minus pi on 3, rearrange all that to get x by itself. It's much easier instead to do the rearranging of our conversion equation at the start to also write it in where it has x by itself. So I'm going to rearrange this conversion equation, so it's going to turn into x minus pi on 3 is to a on 2, so x, I'm sort of just working up instead of down just to fit this in, we get x is equal to a on 2 plus pi on 3. So that's what I'm going to use for all of those. I'm going to substitute each one of these a values in to that. So a is now equal to, let's substitute pi and 2 into this, so what do we have? Let's see. Get x is equal to pi on 2 divided by 2 plus pi 3. We also get 3 pi on 2 divided by 2 pi on 3. We get 5 pi on 2 divided by 2 plus pi on 3, and the last one is negative pi on 2 divided by 2 plus pi on 3. So pi on 2 divided by 2 divided by 2, that's the same as, instead, that's the same as times by half. Well, we can quite clearly see. Dividing by 2 then dividing by 2 is the same as divide by 4. So we get pi on 4 plus pi on 3, 3 pi on 4 plus pi on 3. And there's no way sort of around doing all this unless you're wanting to try to do it on in your head. But you're likely to make mistakes if you try to do that. Now to do these, we just need to make common denominators, so we're going to turn everything into a denominator of 12. So multiply by 3, so that's 3 pi, 4 pi, this multiplied by 3, so 9 pi on 12 plus 4 pi on 12, 15 pi on 12 plus 4 pi 12, and then we get 4 pi on 12, and now we can finally add them. So we get 7 pi on 12, 9 plus 4 is 13 pi 12, 15 plus 4 is 19 pi on 12, and pi on 12. There are our answers, and we'd want to write this 1 pi, like I said in the previous video. We'd probably want to write this one over here first in orders. It was just that it ended up at the end because I did sort of positive angles going around first, and then we tacked on our negative angle. And that was allowed at the end. But yeah, we'd want to try and write these in from smallest to largest. And let's go back and look at our original requirement. Our original requirement was from 0 to 2 pi. Well, 1 pi on 12 is the smallest, that's bigger than 0, and then 19 pi on 12, that's less than 2 pi, because 2 pi written as on 12 would be 24 pi. So it's smaller than that, so that works. And that's our answers. And that's solving there. And you would have to do this, like, the reason why this is equal to 0 is because you could be asked to graph that function and you need to find the intercept. So to find the intercepts, you have to let y equal to 0, and that's why we started with this equal to 0 way back up there. Right, let's do the second example. Down. There we go. I'm gonna go through the same process again, exactly the same way. So very first step is to rearrange to get it. So it's just the trigonometric function on one side, or the trig function on one side. So we get 2 sine 2x plus 2 pi 3 is 1, and then we get sine 2x plus 2 pi 3 equal to half. From there, we will now go let 2x plus 2 pi on 3 equal to a. So we now get sine of a is equal to negative half. Now we just need to find our working domain. So we substitute our original domain, which in this case was negative pi and pi, into our conversion equation. So we get, subbing negative pi in, we get 2 by negative pi plus 2 pi on 3, comma 2 by pi plus 2 pi on 3. So I've just substituted negative pi and the pi to our conversion equation. So our new domain is negative 2 pi plus 2 pi on 3 and 2 pi plus 2 pi on 3, which gives me 2 pi, that's going to be negative 4 pi on 3, and that's 8 pi on 3. So that's my new working domain. So I can put that here. A needs to be an element between negative 4 pi on 3 and 8 pi. Right, so we need sine of what angles give me negative half. So we need a vertical component of negative half. So that clearly means we're going to be in the third and the fourth quadrants. And if we remember our exact values, sort of the reference one will now be, go around to pi, all the way around, and then we need to get, so our vertical component's negative half, which is smallest out of the 3, so that will be pi on 6. So that point there is pi plus pi on 6. So that's 7 pi on 6, so that's effective. Reference, the next one is around at 2 pi. Take away pi on 6, so that will be 11 pi on 6. And we can go all the way up to 8 pi on 3, which is the equivalent of all the way around once, which is 2 pi, which is 6 pi, and then another 2 pi on 3, which would take me to over here. So that's it in all the way around to 8 pi on 3. It doesn't, second lap around doesn't get us back into the third and fourth quadrants, but we need to deal with our negative angles as well. So that, in that case, that's if we were going this way, well, clearly we can get to negative pi on 6 quite easily. That's within negative 4 pi on 3. We can also get round to negative pi plus pi on 6 there. So negative pi plus pi on 6, that would be negative 5 pi on 6. And we're going to negative 4 pi on 3, so that's it, because that there is to negative 3 pi on 3, and another pi on 3 again just gets us up to there, so it doesn't get us back round to the fourth or third quadrant. So that's the 4 angles that all give us a vertical component of negative half. So that's the answer in terms of A, but we need an answer in terms of x. So we need to bring our conversion equation down and now rewrite that so that we get x by itself. So we're going to get 2x is equal to a, take away 2 pi on 3. So we get x is equal to half a minus 2 pi on 3. So that's how we're going to convert them all. Now we can convert back, going back to blue because we're now dealing with x. So x is equal to half pi negative 5 pi on 6 was our first one, minus 2 pi on 3. Next one was half pi on 6 minus 3. Haven't really left myself enough space. Apologise for the poor layout. 7 pi on 3. And the last one is half 11 pi 6 take away 3. Now what would have been smart is realising that all these ones I'm substituting in are pi on 6. So I could have converted this very original fraction here instead to be pi on 6 as well, which is going to make all these subtractions a whole lot easier. So I could have also realised that that's x half a take away 4 pi on 6 would also work. So I change all these to 4 pi on 6, 4 pi on 6, 4 pi on 6, 4 pi on 6. And since the denominator is the same, it's going to make my life a whole lot easier. So I now get x is equal to half by negative 5 take away another 4 is negative 9 pi on 6. Get half by negative 5 pi on 6. Half by 7 take away 4 is 3 pi on 6. And then half by 11 take 4 is 7 pi on 6. Apply the halves, so I get negative 9 pi on 12, negative 5 pi on 12, 3 pi on 12, and 7 pi on 12. There's my answers. Let's go back and check my original domain, which was here. So anything between negative pi and up to pi. Negative 9 is fine, negative 5 is fine, 3 is fine, 7 is fine. So all of those are inside the original domain. So they all work. The very last thing you'd want to do is just check if any of those can be simplified. So negative 9 pi on 12 we can. That turns into negative 3 pi on 4. That stays negative 5 pi on 12. This one turns into pi on 4 and 7 pi on 12 stays the same. So there's your final answer, and that would be possibly the intercepts for that equation if it was y equals, and we've let y equal to 0. There's a lot, like I said in the other video, there's heaps in this. There's just heaps of arithmetic work, heaps of fraction work. you need to, again, can't stress this enough, is this idea of equivalence. There's not going to be just one angle that makes it work. That in our case, for this problem, we had negative half. Sine of something had to give negative half, so that meant we were in the third and the fourth quadrant. Now, if that meant we were one loop around, two loops around, or we were going back negative through the quadrants, yeah, you have to be really careful. Make sure you pick up all the angles that can work. Yeah, that's it. I just want to show that this is another way of just laying it out. Might be a little bit easier for you with this idea of convert the problem to A. So if we've converted our problem to A, we need to convert our domain. And this converted domain is a little bit easier to work with, maybe for some people. Seeing it written as in terms of A and solving for A. Then once we've got our A values, we need to convert them back to X. And as long as we converted our domain properly, once we convert back to X, our final answers should be within the original domain and work fine. Yeah. Have any questions? Please email. Ask in class, put a comment below, or put something on Google Classroom. Here to help. So, yeah, please do. Other than that, have a good evening.